I'm quite interested in this kind of algorithm design and optimization. However, it seems that nowadays lots of so-called deep learning and lots of AI applications dominating the research field, right? Like the ChatGPT, other um, like image generating image, that kind of AI application is quite eye-catching and useful in a way. So I'm interested in discussing how the optimization and computer algorithm can be used in the future of our world. Like how can we develop them so that they can have a pace in those state of the art um, or commercial applications. So what do you think? Like how can we integrate or what is the appropriate direction of that algorithm in the future?
So, well, maybe I can answer this. So basically, for the same reasons that you mentioned, that ML algorithms are improving a lot, we try to use actually these algorithms and the prediction they kind of can give us and improve the theoretical results. So basically, the main problem they have, which we try to answer, is that they are not robust. So although they are practically speaking very well and efficient, we have no idea how bad they can be in the worst case. That can happen rarely. And using theoretical ideas, we try to robustify them actually. So the idea of learning augmented algorithm, merging these two worlds of machine learning and theoretical computer science actually has this purpose of merging, using these improvements and also merging these theoretical results and efficiency and robustness results together. So we are happy that they are improving. We just help them to kind of being robust.
Thank you, and thanks for the good questions, Kai. And maybe in my team here, so my supervisor Chao, and he is in his PhD, and he is mainly do the theoretical analysis. And in the beginning of the tenure track, and he also doing some theoretical. And I am his second PhD student. And my first. His first PhD is also doing some theoretical analysis of evaluation algorithm and multi-objective automation. However, me in his group, and I am the student that is focused on the design of algorithm and make them to many applications. So in my opinion, I have to say that the theoretical analysis of the algorithm is essential for the algorithm design and application. So in my research process, and my supervisor can give me many insights from the basic and the theoretical perspectives, and can help me address some challenge during the applications. Okay, so the first, I think the first point is that the theoretical understanding of an algorithm and especially the optimization of algorithm is very important and very essential for many application tasks. And the second one is, as Kai you mentioned, there are many work such as the machine learning, artificial intelligence, and recent the large language models. And the optimization plays a very important role in them. And there are also many such as the Adam, some updated version of Adam optimizer paper, and many paper are from the just to improve the algorithm performance from the theoretical perspective. Now, also the theoretical maybe not so rigorous, but it can provide some insight for the mechanism design of the algorithm. So I think maybe there are many new problems, and maybe it has not very hard, but it can be useful to guide the advanced method, and we can maybe can also improve the make the application performance better. Okay.
Yeah, cool. So let me repeat US questions. So this time in this talk, we have both presentation from the algorithm design for machine learning and quality diversive. So can both of you comments on the potential of these two research field overlapping and how it can be adapted to in reality problems.
So let me start by answering the first question, maybe. So as I said, the learning augmented algorithms the high level idea comes from both of this area of theoretical computer science, and machine learning. And I told you that we get some prediction and blah, blah. But I should mention that right now we don't have any assumption on the quality of this prediction. So we get this prediction as a black box. So I think the next steps would be to complete this bridge between these two areas and trying to actually have some assumption about this prediction that machine learning algorithm can introduce, right? And basically, if we can merge these two areas such that we can improve the quality of the prediction or have some assumption regarding this prediction, therefore we can improve the performance guarantee we can also provide. And regarding the second question, how can we use it in the real life scenario? So most of the problems we are dealing with are repeating every day, right? If we solve a scheduling problem, let's say, if we are having a company and we want to schedule something today, probably we should repeat it tomorrow or next week or next month, right? We don't want this problem to happen just once. And we can use the data of the previous scheduling or whatever problem that we are dealing with as a prediction to improve our current performance. And in theoretical computer science, we try to formalize these things. We try to give proofs, theoretical proofs to basically prove that this for sure will happen. This is the guarantee we can guarantee. And we're just trying to basically use these tools, these predictions, ML algorithms to improve the guarantees that we can give. So, yeah.
Any
Okay,
comments
thanks
from
for
you? Yeah.
Okay, yeah. Okay, thanks for the questions. And my comment is that when we apply the quality diversity to different scenarios, not only the the mechanism design, algorithm design, and other reality problems. So the first one is to figure out which one we want to be diversified. So just an example. For example, when we want to using some learning method to augment the algorithm. So the first one is maybe that where the data from. So how can we get the enough data to make them to be learned? And here in this problem, the QD the QD algorithm, or maybe the idea of QD, can be used to make the data for learning is diverse. For example, we want to a solver, they can solve the different and diverse instance, and that is we want to it to solve different tasks. And here the QD can use to generate the synthetic data to be used for the instance generation and others. Okay. So the first one is to figure out which one we want to be diversified. That is to define the diversity And the second is want to the quality. However, the quality is usually easier to be defined. For example, we can use the accuracy, the optimization efficiency, and others. So given this one, and the QD algorithm can be adapted from the original framework, and then we should to define some specific operators to make them more efficient, and then we can run the algorithm to achieve our goals. Okay, so yeah, that's all.
Yeah, thank you. And I think what my last question is that since both of you are PhD students, so sooner or later you'll be graduating from the university. So what would be your, I mean, research field or technology that you would like to work on after graduation, like maybe say within 5 years? So what will be the next thing you want to do, or keep on with the same research field?
So I think I cannot answer this question because the field I'm working on basically introduced in 2018. And I believe that we should move, or change our direction of the research with the new technology that comes, and kind of be flexible to be able to improve the problems that we are dealing in that time. So I'm not sure what I will work on, but I'm pretty sure that I'm not working on the problem or settings that I'm writing right now, because I hope that everything improves and we are dealing with other problems and not stuck with the current problems. But yeah.
Okay, thanks for the questions. And maybe during my research process, I find my current research area, that is the black box optimization, is very important and has a very widely applications. So maybe when I graduate, I will continue to do research in the university, and we want to design better algorithm, design better theoretical understanding, and make them to be applied to many the real world problems. Yeah.